Hello students. Tomorrow in class we're going to be doing a lab. In the lab we're going to be looking at how fast does a rock weather. And if you remember what weathering is, it's how fast, it's the breaking down of a rock. Remember we talked about the difference between weathering and erosion. Weathering is the breaking down of a rock, erosion is the carrying away of a rock. Today we're not focused on erosion. We don't care about erosion. We're not worried about how fast that sediment is carried away. We're looking at the process of the rock breaking down into sediment. And we want to know how fast does this happen and what factors affect the rate in which the rock is broken down into sediment. So to do this experiment, you're going to be given some materials. You're going to be given 8 effervescent tablets. Alka-Seltzer is a type of effervescent tablet. This package has 2 Alka-Seltzer inside, so 4 little packages will be your 8 effervescent tablets. You're going to be given 8 plastic cups. Now, you're going to have to rinse these out and return these at the end because obviously we're not going to throw away all these plastic cups and never use them again. You're going to be given a graduated cylinder, and you will have a timekeeping, a stopwatch of some device. The other thing, of course, you'll be using is your safety goggles. Yes, it is important to always use your safety goggles. You will notice that I am not currently wearing my safety goggles. I do not have a good reason for that. My only reasoning is I'm making this video at home. Due to COVID, I do not have my safety goggles here, but I will be only using these antacids or these effervescent tablets in accordance with the manufacturer's specifications. In the classroom tomorrow, you will be experimenting with them. There will be more danger to it, so you will need your safety goggles. I am only doing exactly what it says to do on the package. Okay, so what you are going to do is you are going to consider your effervescent tablet your rock. Think of it as a rock. And you're going to be doing experiments to see how fast this rock will break down into sediment. So let's talk about an experiment. We did experiment. We talked about the scientific process at the beginning of the school year, but remember, in an experiment, you form a hypothesis. You say what you think will happen. And then you conduct your experiment. But in your experiment, you need your control group and you need your experimental group. Your control group is the group where nothing changes. So let's think about our control group. In your control group, you are going to take room temperature water. Now, room temperature is not a very scientific definition of the temperature of water, but it makes it easy for conducting the lab in the classroom. So we're going to use room temperature water, and we're going to use 120 milliliters of it. Why are we using 120 milliliters of water? Because it is approximately 4 ounces, and that is the manufacturer's specification on the Alka-Seltzer. So here is 100 milliliters, and I'm going to add another 20. Here's 20 more milliliters. Now, what I'm going to do is I'm going to dissolve an Alka-Seltzer in this water. Now again, in the classroom, you will be wearing your safety goggles. The only reason I can get away without doing that right now is because I am not using this Alka-Seltzer in any manner outside of the manufacturer's specification. I am doing exactly what the directions tell me to use, tell me how to use this. Now, before I dissolve this Alka-Seltzer in the water, I am going to get my stopwatch ready. So I have my stopwatch, and I'm going to drop this in, and immediately I'm going to start my stopwatch and see how long it takes this effervescent tablet to dissolve. Are you ready? Okay. 1, 2, 3, drop, and I've started my timer. Now I'm going to turn the time away from you so you can't actually see how long it takes, because I want you to get to experiment with this in the classroom. But one of the things we do have to be careful with is we have to have a very standard time in which we consider the tablet fully dissolved. So I can see it's still bubbling, and I'm watching it bubble, and I'm watching it bubble, 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 bubble. Oh, I can still see the tablet at the bottom. That's why we're using the clear tablet instead of, the clear glass instead of any kind of glass that's not clear. We're also using plastic instead of glass just because it's safer. There's no hazards, no worry about breaking something that is glass when we don't need to deal with glass. It's bubbling, 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 and right about, I can hear some bubbling, I can still see a little bubbling, and now I'd say the tablet's gone. Okay, so I have my time, but I'm not going to share that time with you. I'm not going to tell you how long that was, but that is my controlled experiment. Now, let's talk about sample size. Anytime you conduct an experiment, it's better to have a larger sample size, meaning you do the experiment more than once. So I have a time here, but you know what? I'm actually going to do this 2 more times. I'm going to conduct this exact same experiment 2 more times and make sure that I get roughly the same amount of time for each of these 3 control group experiments. Now, in the interest of saving Alka-Seltzer tablets, we won't be able to do 3 tablets in each group like we did in our control here. But I'll repeat this a second time, repeat this a third time. Okay. After you do that, that's when you get to start having some fun. All right? Because now you get to start experimenting with what will change the rate at which this effervescent tablet dissolves. And remember, in an experiment, you have controlled variables, and then you have your independent variable and your dependent variable. Now, your independent variable is the one thing you're going to change. And this is where you get to have fun. What are you going to change? What is the one thing you're going to change about this experiment? And your goal, you have 2 goals. To try and make the effervescent tablet go faster, and to try and make the effervescent tablet dissolve more slowly. What one variable can you change to make this effervescent tablet dissolve more rapidly? What one variable can you change to make this effervescent tablet dissolve more slowly? So, the first thing you need to do is think about, what are all the variables? The type of glass it's in, the amount of water, the temperature of the water, the medium in which the effervescent tablet is dissolved, that means it's dissolved in water, the altitude at which I conduct the experiment, that would be pretty hard to change the altitude, the type of tablet that I use. All of these things could be changed, but they're going to be kept exactly the same, because those are the control variables, except for one variable. What is going to be your one independent variable? What one thing are you going to change to see if it makes this effervescent tablet dissolve more rapidly? Or what one thing are you going to change to see if it makes the effervescent tablet dissolve more slowly? It will be your task to conduct 5 experiments, because you'll get 8 tablets. 3 of them are for your control group. The other 5 are for experiments. Each time you're changing one variable, changing one thing to see if it causes the effervescent tablet to dissolve more quickly or more slowly. At the end of your project, you will need to At the end of your project, it will be for you to say what you think will cause an actual rock to weather more quickly and what you think would slow the process of rock weathering. Things you will have to be able to do is define your independent variable, your dependent variable. Your dependent variable is time, isn't it? Because we're talking about speed, your dependent variable is time. I just gave you the answer. But your dependent variable is time. And your controlled variables are all the things that you don't change each time. Okay, that is all. I'm looking forward to seeing you conduct your labs tomorrow. Thank you, class. Bye-bye.